Right, so to go to that point, I can either follow R, or I can go horizontally a little bit and then vertically a little bit. So to get to that point, how much is that horizontal distance that I have to travel? 4 units. And how much is that vertical distance that I have to travel? 5 units, right? And that's the coordinate 4, 5, right? And, okay, so what about that radius? Would I be able to figure out what that radius is? Yeah, how? The Pythagorean theorem, right? I could say r squared is equal to 4 squared plus 5 squared, right? And then r is root 41. So this is root 41. Okay? So now, when I drew that radius to that point P at 4, 5, what I also did is here I created an angle theta, right? Okay. Now, if I were to ask you, what is the sine of theta, right? We know that's opposite over hypotenuse, right? So in this case, what's that opposite side? 5 over the hypotenuse is root 41, right? Okay. And then what is the cosine of theta? It's adjacent over hypotenuse, and that's 4 over the radius, root 41, right? So look at what you notice here. Do you notice that the sine of theta, yes, it's the opposite side, but it's also this vertical distance, right? That vertical distance, 5, is 5 units along the y-axis, isn't it? And the horizontal distance, the adjacent, that's the horizontal distance along the x-axis, that's a unit of 4, right? So we notice that the opposite side is actually the vertical side, or y over r, and cosine is the adjacent side, or the horizontal side, or x over r, right? And then what else do you notice here? At the very, very beginning on the first page, right? Do you remember how I told you that we're always going to look at that opposite side as the vertical side for the sine and the horizontal side as the cosine, right? So it all ties back into that, okay? So going back here now, could I have also gotten these values from the coordinates? Yes. I could have, right? So that's all I need, it turns out, to find sine, cosine, tangent. If I know the point P, the angle that it makes, the sine of it is the y value over r, and the cosine is the x value over r. All right? So this now becomes a very, very important concept. So sine is always going to be associated with y, or the vertical. Cosine is always going to be associated with the x, or the horizontal. Okay? And the sooner you make that association in your mind, that sine is the vertical side, cosine is the horizontal side, the easier things will be for trig. Okay? So then, if I wanted to find cosecant, then it's just the reciprocal r over y, and so on and so forth. Okay, so now let's do an example with this. All right, so we have a point, negative 4, 3, negative 4, 3, on the terminal side of an angle theta in standard position. We want to find the exact values of the 6 trig functions of theta. Okay, that means we want to find sine, cosine, tangent, and all the rest. Okay, for this first one, I'm just going to sketch this so we can see what we're looking at. So negative 4, 1, 2, 3, 4, comma 3 is here. okay? When I draw the radius, that's where that lies. And so now, take a look. I can go from the origin to that point either along the radius, or I can go across a little bit, horizontal a little bit, and I can go up a little bit, okay? So the first thing I want to do is I want to find the radius, right? So my horizontal side is 4, or actually, negative 4, because it's in the negative direction. The vertical side is 3, right? Here. Sorry, it's so tiny. So R, how am I going to find R? R squared is equal to 3 squared plus 4 squared. How much is R?
5.
It's 5. Okay. If you can figure out that that's a 3, 4, 5 triangle and just say R equals 5 without actually writing out the Pythagorean theorem, it's totally fine, especially in this level, right? If you can't write it out, I'm not really, looking for work here. That's not the, the point of this exercise. Okay, so now I want to find sine of theta, cosine, and tangent. So where is theta? Theta is always that angle between the x-axis and the radius. Always between the x-axis and the radius. So now, sine of theta is the opposite side, which is the y value, 3, over the radius, which is 5. Cosine is the x value, 4, but in the negative direction, so negative 4 over the radius 5. Tangent is y over x, opposite over adjacent, so that's 3 over negative 4. Yeah?
I thought that sides of a triangle, or like in general, they couldn't be negative.
So the side isn't, but you're going to see later that sine and cosine are actually the coordinates of where that point lies, right? So it's not just like the square, like the absolute value of the side. Okay? Yeah. And then, so now cosecant of theta is 5 over 3. Secant of theta is 5 over negative 4. Cotangent of theta is negative 4 over 3. Okay, now, did I need to draw that diagram? I really didn't need to draw the diagram, because when I'm given that point, in that point, I have all the information I need. I can just call that value x, call that value r, y. I can find r using the Pythagorean theorem, and then all I need for sine is it's y over r, x over r, y over x. Okay? Okay. All right. Let's pause for a minute and look at that relationship between sine, cosine, and tangent. In the first lesson, we said tangent of theta is also sine of theta over cosine of theta. You remember that? Okay. Well, here in this problem, what's sine of theta? From here? Right, which is 3 over 5, right? Sine of theta. Cosine of theta is negative 4 over 5. Okay? So now we have a complex fraction, a fraction within a fraction. How do we simplify this? Well, there are two ways. One way is you can do 3 over 5, and if you're dividing by a fraction, it's times the reciprocal, negative 5 over 4. right? So those cancel and you get negative 3 over 4. Look, that's the tangent, okay? Another way to do it is, which is what I would like for you guys to get used to, is here within the complex fraction, look, you've got numerator, denominator, numerator, denominator. Look at the denominators here. You have a denominator of 5 and an identical denominator of 5. When you've got identical ones like that, they cancel. So now, this is the main fraction, right? On top, you have 3. On the bottom, you have negative 4. So you come to the same conclusion. Okay? All right. Right, so what if your point is not at a random place like that? What if your point actually lies on one of the axes? What if your point lies on top of the x-axis here? What then, right? In that case, right, because it's not in the middle of a quadrant, it's on the x or y axis, we call those quadrantal angles, right? This is when the terminal side lies on one of the axes, okay? So now, the concept is the same. What were we doing before? We had an x coordinate, a y coordinate, and we had a radius. Okay, any point still has an x and a y coordinate, right? If I have a point here, what would you say would be a possible, a reasonable coordinate for that point? Anything. There are millions of answers. What do you guys think? 8, 0, right? Okay, so a reasonable value would be 8, 0. Now, if that was 8, 0, what did I say the radius was? The radius is the, it's the distance from the origin to that point, right? That's what the radius was here, the distance from the origin to that point. How big is the radius here? 8. So now, look at this. I've got an x coordinate, a y coordinate, and a radius. Yes? Can I still apply those formulas from the top of the page? I can. Okay, so now here, if my angle is here, how big is the angle if the point is there? 0 degrees. So now, instead of saying sine of theta, I'm going to say sine of 0. Okay? Is equal to y over r. The y value is 0, r is 8, so that's just 0. Okay? Now, the cosine of 0, then, is x over r, right? The x value is 8, the r value is 8, so that's just 1. Okay. So now we start to think, wait a minute. Does it have to be 8? What if it was 3? What would it be then? If that was 3, what would the radius be? 3. So what would x over r be? 1 again. So then, for the sake of simplicity, we always choose the coordinates to be 1 unit away. So instead of 8 and 0, we like to choose 1, 0 with a radius of how much? 1. So now, does this still work? It does still work. So then what would tangent of 0 be? It would be y over x, 0 over 1, 0. Okay? Now, let's do the reciprocals. Cosecant of 0, it's the reciprocal, right? It's 1 over 0, which is undefined. Secant of 0, 1 over 1, which is just 1. Cotangent of 0, 1 over 0, undefined. Okay. you are not allowed to leave it as 1 over 0. You must say undefined because the person grading your paper needs to know that that's undefined, right? You're also 1 over 0 is a number that doesn't exist, so you're not allowed to have that as an answer, okay? All right, so fine. What if my point is here on the y-axis? Now, a possible coordinate point for that could be 0, 1, right? X is 0, y is 1. So what's the radius there? 1. Okay? The radius, Ben, always has to be positive because that's a straight distance. The x or the y, it's a location. Okay. So now, here, my angle is 90 degrees, right? So I'm going to say, okay, sine of 90 degrees is y over r, 1 over 1, which is 1, right? Cosine of 90 degrees is how much? What do you guys think? 0 over 1, which is 0. Okay? How about tangent of 90? 1 over 0, undefined. Okay? Okay. When my point is here, yeah. Huh? Okay. It's up to you. You can go. Okay. So negative r comma 0, right? So here, a possible coordinate point would be negative 1 comma 0. All right? And r is still 1. So let's just do cosine for this. The angle here is 180. So what's cosine of 180? X over r. Negative 1 over 1, which is negative 1. Yeah.
You want us to write 180 or to write pi?
Either. Normally, like you would be asked, cosine of pi or cosine of 180. Last but not least, my point could be here, where it makes an angle of 270 degrees, and a possible coordinate there is 0, negative 1. So what would be, let's do secant of 3 pi over 2 this time. Okay? Secant is like the cosine. So it's r over x, 1 over 0, undefined. Okay? So, negative. No, sorry. It's r over 0, 1 over 0. It's the secant. Okay. So, how do these come up? Well, you're in a problem. You're just going to have to evaluate something like this, right? Cotangent of 7 pi over 2. This could be a standalone problem, or it could be within a longer problem. So now I need to find cotangent of 7 pi over 2. First and foremost, I need to locate where this angle is located. So 7 pi over 2 is like 7 over 2 pi, is it not? 7 over 2 is 3.5 pi, right? Again, this is the only time in my life that I use mixed numbers. No math teacher likes mixed numbers. No high school math teacher does. This is literally the only time that I use mixed numbers. So now let's sketch. An angle always starts at 0 degrees. Now, I'm going to draw an angle of 3 pi. So follow me here. 1 pi, 2 pi, 3 pi, correct? And then I need another half a pi. How much is half a pi? 1 quadrant. Half a pi. So look at where my point ends up. So my radius is here. Okay? So I don't care how many loops it took to get there. A possible coordinate point there is 0, negative 1. So now, cotangent of 7 pi over 2 is x over y, Negative 1 over 0, undefined. Okay?
Is it 0?
Oh, I'm so sorry. It's 0 over negative 1, which is 0. Okay? All right. Now let's do 450 degrees. Again, I would like you to be equally comfortable with radian and degrees. So if a problem is in radian, work in radian, and if it's in degrees, work in degrees. So we start here at 0. Okay, so 180, 360. How much more do I need to go to make it 450? 90 more. Right here is where I end up. So that's my angle. The coordinate there is 0, 1. Tangent of 450 then is y over x, 1 over 0, undefined. Okay? Questions? All right. So now, the big idea of trigonometry, okay? The unit circle. Okay? All right. The unit circle. This is everything. This is the one thing that everything is based on in trig. It's the unit circle. Everything just goes back on the unit circle. Now, you do not, okay, so we're not going to do things like memorize the unit circle, okay? In fact, memorizing things is one thing that I never want to see any of my students doing. What we're going to do is we're going to understand where things come from, all right? So, and hopefully after we're done with all of this, with this, lesson, with a couple of more lessons in this chapter, we're going to be able to evaluate trig functions without any aids, right? Without any unit circle, without any of those charts that I see like students drawing all the time, right? We're going to throw all of those out because we're just going to know how to do them. That's the expectation, right? So that's where we're heading towards. Okay. The unit circle is just a circle with radius 1 centered at the origin. Okay? That's what the unit circle is. So, here we go. We have a unit circle with a radius of 1. Now, if the radius of this circle is 1, then we run into a couple of problems. So one problem is this. Okay. Remember the special right triangles? No, the 30, 60, 90 triangles, right? So look, this is a 30, 60, 90 degree triangle, okay? So if I have a 30 degree angle, that's like a pi over 6 in radian, right? If I make a 30 degree angle, that's what it looks like there, okay? It intercepts the circle at a specific point, right? So now, if I label this triangle here, like I normally do, 1, root 3, and 2, right? Well, if I were to take this triangle, this is the 30 degree angle here now, and try to put it into the circle, it's not going to fit. Because what part of this triangle will correspond to the radius over there? The hypotenuse. But the hypotenuse, the radius here must be a 1. This is a radius, this is a hypotenuse of 2, so this can't possibly fit in here, right? That means what I have to do is we have to rescale the special right triangles so that they do fit in there. Okay? Okay, so I have to rescale it like Photoshop style, proportionally. So if this has a side of 2 and I want to make it a 1, what am I going to do to it? I'm going to divide by 2, right? But I have to proportionally do the same thing to all of them, right? Divide by 2, divide by 2, divide by 2. Okay? So now what I get is a new triangle, the sides of which are 1, 1/2 root 3 over 2. Now, here's the big deal. Look at this triangle. Let's find the sine of 30 degrees. What's the sine of 30 degrees? Opposite over hypotenuse, right? Well, what's the sine of 30 degrees here? What's the opposite side? 1/2 over what? 1. Oh, that's just 1/2. Because when you divide by the hypotenuse, it's 1, so it doesn't make a difference, right? So sine of 30 degrees might as well be just the opposite side. So now what's cosine of 30 degrees? Root 3 over 2. No more having to divide by 1. It's just the adjacent side. No more adjacent over hypotenuse, because the hypotenuse is always 1. Right? So now if I were to ask you, what's the sine of 60? Sine of 60 is just the opposite side, root 3 over 2. Right? Cosine is just the adjacent, 1/2. Okay? Of the 60. Yeah? Okay, yes. If it's tangent, it was always opposite over adjacent, right? So 1/2 over root 3 over 2. And they both have the same denominator, so it's 1 over root 3, just like it's always been. Okay? Okay, nothing changes. It's consistent. So now, on the unit circle, let's take that triangle and bring it to the unit circle. On the unit circle, the angle that we're going to be talking about is always this angle. So now this is a 30-degree angle on the unit circle. Let's fit the rest of the triangle here. Do you see how I still have my 2 sides of the triangle? Right? I have a longer leg and a shorter leg. Okay? Now, this shorter side is always going to be 1/2. The longer side is always going to be root 3 over 2. So now, remember, okay, so what I'm trying to get at is this. Remember how, back in the day we had SOHCAHTOA? When the hypotenuse is 1, that h just goes away because the hypotenuse is always 1. So sine is just the opposite side. Cosine is just the adjacent side. Okay? Now, so looking at 30 degrees here on the unit circle, what's sine of 30 degrees? 1/2, because it's the opposite side. What's cosine of 30 degrees? Root 3 over 2, because that's the adjacent side. Now, one more thing. Remember how we started this lesson? We had a random point, and we said the distance from the origin to that point was our radius r. So I said it was all about getting to that point. To get to that point, I can either follow the radius, which has a length of 1, or I can go along the x-axis a little bit, and I can go along the y-axis a little bit. If I go this much along the x-axis and this much along the y-axis, what are the coordinates of that point? It's root 3 over 2, comma 1/2. What? Where did that come from? Let's see. Look at this. Remember, we went along a distance of 4 and up a distance of 5. So what's the coordinate of that point? 4, comma 5. Yes? So here, the coordinates of that point are root 3 over 2 and 1/2. Right? What were those points also? Cosine of theta and sine of theta. Cosine of 30 and sine of 30 are also those points. So the point on the unit circle, where if you have a 30-degree angle, the point that it intercepts on the unit circle, the coordinates of that point are the sine and the cosine. Okay? So now, suppose instead of a 30-degree angle, suppose now I have a 60-degree angle. Why can't I erase that? Okay, it won't go away. Okay, suppose now I have a 60-degree angle. Okay, 60 degrees, one sec. Okay. Now, if that's 60 degrees, look at the triangle now. The sides of the triangle are still the same. One is root 3 over 2, one is a half. But where are they now? This is the half, and this is the root 3 over 2. So now, just by looking at that triangle, what's the sine of 60 degrees? Root 3 over 2. So sine is always the opposite or the vertical. Okay, so let's think of it this way. When I have a 60-degree angle and I'm trying to intercept the point on the circle, sine is always the vertical, cosine is always the horizontal. So if it's about intercepting that point, if I ask you sine of 60, it's how high do you have to go up? If I ask you cosine, it's how much horizontally you have to go. So the way Miss Malikian, thinks about it is this. If I need to figure out what the sine of 60 is, I say, okay, that's the larger angle, so I have to go up much higher. So sine is root 3 over 2, and the cosine is the smaller one, 1/2. Okay? All right. Now, what about the 45, 45, 90? Yep. How come I can't erase anything? Huh? I'll put it all together in a little bit. Okay. What about the 45, 45, 90? The 45, 45, 90 has sides 1, 1, root 2. Root 2 is like 1.4, so I still have to scale it down. So I divide by root 2, divide by root 2, divide by root 2. So for a 45, 45, 90 triangle, okay, so for a 45, 45, 90 then, okay, so if this is 45 degrees, okay, it used to be 1, 1, root 2, but now this is a 1, so I have 1 over root 2, 1 over root 2, okay? So whether it's the sine or the cosine, right, what's the sine of 45 degrees then? 1 over root 2, and what's the cosine? 1 over root 2, okay? So it's all about, all right, if I'm asked for sine of 60 degrees, I think to myself, okay, 60 degrees, that's the larger angle. So to go up there, you have to go up a longer distance than you have to go horizontally. So that's the root 3 over 2. Okay? If I'm asked for the cosine of 60 degrees, I say, okay, that's the larger angle. To get to that point, I have to go horizontally shorter than I would have to go up. So the cosine, since the horizontal side is the 1/2. Okay? So that's how it's got to be. Now, when we get back, we'll look at a little bit more of the patterns on the unit circle.